in looking at the dx terms, these terms combine together. So I have 2u dx, u dx. There's 3u. So I have 3u with the dx. And I also have a dx term over here, plus u to the third power. So that's my dx term. My du terms will be these two terms. And I can factor an x out. So it's plus x parentheses 1 plus u squared du. And all this equals to 0. Alright, so can we separate terms? Alright, I believe we can. So I'm going to take this to the right side, and this gives me 3u plus u cubed parentheses dx equals to minus x 1 plus u squared du. And let's divide by x and divide by 3u plus u cubed. And so dividing by that term and this term, and we'll see what we get, because this looks like it will separate the variables for us. On the left side I've got dx over x. On the right side, these x's will cancel, and I get negative parentheses 1 plus u squared du over 3u plus u cubed. There we go. So we have separated the variables, and which means we can now integrate. We can integrate this thing. Now it turns out this problem has been rigged in our favor. Okay, a lot of these book problems are organized so that the integration, the final steps are not all that tough. Thank goodness, because I'm noticing that if we take the derivative of the denominator, we'll get 3 plus 3u squared. That's 3 times this factor. So we can approach this sort of the calculus 1, calculus 2 way would be to let a different variable other than u, let some variable equal to 3u plus u cubed, and then do that substitution. I tend to, when we get to this level of calculus, I tend to try to skip a few of those substitution steps. So try to follow me on this. I'm seeing that this derivative is 3 times this parentheses. So I'm going to put a 3 here and a 1/3 out front. So the 3 and the third would cancel. And that means that this is equal to negative 1/3. So negative 1/3 integral differential of 3u plus u cubed over 3u plus u cubed. So follow me on this. This differential is 3 plus 3u squared times du, isn't it? Right, so this equals out, and what do we have? This is a logarithm form, isn't it? It's a dx over x form. So this antiderivative, this integral, will be a logarithm. Alright, well, I need to make some more room here. Okay, so let's integrate. Here I've got natural log absolute value of x equals to minus 1/3, and again, here's a logarithm, natural log absolute value 3u plus u cubed, and then we need our plus c somewhere, okay, our plus constant. How about we multiply everything by negative 3. So I'm looking forward ahead to simplifying this mess here. If I multiply by negative 3, I'll get minus 3 natural log absolute value of x equals to natural log absolute value of 3u plus u cubed plus a constant, right? Because negative 3 times a constant is still a constant. So, again, we can play kind of fast and free with our constants. So I'm renaming my constant as c. Okay, now let's, if I were to, let me see, how are we gonna finish this thing? If I were to combine this to over here, add it, then I'll have a, here's what I'm going to do. I'm going to bring this to the right, I'm going to bring my constant to the left, and this is going to be natural log of 3u plus u cubed times x to the negative third power, all in absolute value, equals to a constant. So constant comes to the left, becomes negative c. Well, it's still a constant. I'll call it c. And this exponent, you know, the logarithm rule says I can take this exponent up here, make it x to the negative third power. I think I got a mistake here. I think I made a little mistake cutting corners, because let me go back here. I'm skipping steps and don't want to lose anybody. Let me try this again. I'm going to add this term and subtract that term. So I have natural log absolute value 3u plus u to the third plus 3 natural log absolute value of x equals to a constant. Alright, so I added this to the right. It became the positive 3. And the constant, although I subtract it, becomes negative c. I'll just call it c. It's still a constant. Alright, so here's my point. This 3 can be transferred up to here to become x cubed, one of our logarithm rules. So I can make this x cubed, and because I'm adding logarithms, I can multiply it together. So I have one big happy logarithm, natural log, absolute value, x to the third, parentheses, 3u plus u cubed equals to a constant. Alright, that's where I wanted to get it. I wanted to combine the logarithms together and to one logarithm, and that makes it easier to eliminate the logarithms. How? Make them an exponent of e, natural base e, and that will cancel the e natural log, and e to the c, guess what? We'll call it c. Still a constant. Alright, so now we're about there, and got to do a little more erasing. So we're at this stage. I rewrote it up here, x cubed parentheses 3u plus u cubed equals to c. And what I was waiting on, why I wasn't erasing this, is because I want to go back and get my x's and y's. So I'll let u equals to y over x, so I have x cubed parentheses 3y over x plus y cubed over x cubed equals to c. And now let's multiply the x to the third power through there, and we'll get 3x squared y plus y cubed equals to a constant. So let me erase that. There we go. Alright, always like to trust but verify. Check the book here. And 3x squared y plus y cubed equals constant. Exactly what the book got. So, alright, we pulled that one off. Alright. And it is possible to solve for y, but it would be a very complicated expression because this is a cubic polynomial. So it's best to let that sleeping dog lie and just leave it in this form. All right, well, let's look at another example.